Hi, my name is Chimezo, but you can call me Mezo for short. I am a web developer, and today I'll be talking about a more efficient way of handling password resets. So here's the thing, a lot of the content I'm about to share to you in this video would directly be attributed to the Django framework. Now, typically as a developer, most of the code I have been written has been out of frameworks, like writing the code from scratch myself, building what needs to be built. And yes, I know you might be wondering, am I one of the developers that swears against frameworks? No, actually. I believe using the right tool for the right job matters the most. And while some developers would say frameworks are very limiting in what they allow you to do, some other developers will tell you that frameworks provide some structure and they prevent you from writing things that you often have to do. Now, I believe the best approach is to use frameworks when necessary, or at least use them as a sort of learning process. Because if you feel a framework is too limiting, it could be one of a couple of reasons, anyways. One of which could be that maybe you just don't know enough about the framework to do what you're trying to do, and therefore you're trying to force behavior that already exists, but not just in the way you anticipate. That's one. Another reason could be that, oh, maybe what you're doing isn't optimal because, to be honest, there are like bad practices that go or that can very often happen from writing code yourself, like without any form of framework or skeleton. And some other times it could really just be that, okay, well, this functionality you want, it does exist, but you're going to have to conform to some certain type of patterns. So, like, enough talk about the framework. Now, typically, when handling a password reset functionality, again, this is by me. The the way I would do it in the past, and this is me like openly admitting that I'm not perfect. So we all have ways of doing things, and we could do certain things a certain way, then realize that there's a more efficient way of doing this. So I would typically have a user model that contains some data like the password, the email, maybe the phone number, depending on the type of authentication system I'm working on, and some extra fields like the last login and blah 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 that are more specific to the project at hand. So if I were to reset a user's password, again, reset not to be mistaken for password change. The difference being that a password change would be when you're already logged in, but you want to change the password you have. It could be a case of maybe another platform or service you use has like a database or password leak, and one of your frequently used password is there, so you decide to change it on the different like services you use. So with a password change, you would have already been logged in, but like with a password reset, you don't even remember your password altogether. You're like trying to change it afresh, almost as a logged out user. In fact, more often than not, as a logged out user. So typically, when working on something like this, I would have, on some cases, a token table where I would have a token I generate based off of some constraints. Um, then I would have possibly a reference to the user this that this password reset functionality in this particular instance is for. Then when a user would try to reset their password, I would generate the token, save it somewhere in the database, send them the token. It could be a token being used loosely. It could be a string, it could be a 6 digit character, it could be an alphanumeric character, whatever it is, provided that it's some form of pass, a gate pass that says, oh yeah, if you are this person, this is the gate pass that can only be used by you to reset the set password. And then when the user would click the link, or in the case of just applying some like filling in the boxes for the numbers or the alphanumeric string, I would then check that it matches what is stored in the database and give the user access to reset their password if the rest of the constraints are met. Now, this would typically be the flow I would do anytime I'm working on something. So, but of recent, I was playing around with a Django project that I wanted to do, and I used the Django authentication view. Now, the Django authentication view is a set of views. Here's the docs, or let me show you how to spin up the Django docs for this Django auth views. I promise this will not be a lesson in Python or Django, just to show you the thought process that I used in discovering how it worked in Django. So let's say Django auth views. If you scroll up to like the navigation panel, you could just see all of them. So there's like for login, sign up, log out, well, not sign up, login, log out, password change, password resets, etc. All these things are like batteries included in the framework. And I decided, oh yeah, I was definitely going to play around with the forgot password. Now, to check how Django did theirs before and after, I used my database viewer to view the state of the database before a password reset was requested and after a password, example.com, and after a password reset was requested. And guess what? Nothing changed. So when nothing changed, naturally I was very surprised and I was curious to see what happened. And my first theory was that, okay, maybe Django doesn't use the token table to do this. Maybe perhaps it uses a separate token like in the user model. And I inspected the user model. To my utmost surprise, there was nothing there. So naturally, I peeked into the Django code in the auth views, and I found this password reset token generator. These were the constraints that it used in generating its token with a timestamp, but still no mention of how to store it. But now here's where it gets interesting. It doesn't store it. In fact, there is really no need to store it. This particular piece of code here is the most pertinent to this video, and because this is Python, some of you may not be aware of how Python works. I would skip the Python part and just go straight to the explanation. Now, we have the token that gets sent to the user being the user primary key, the password, the login timestamp, and the email. Now, how this works would be typically if a user wanted to reset a password, again, reset, not change, it would be from them not remembering what the previous password was or not being logged in. So meaning the login timestamp, now this is really crucial. The login timestamp would be for the last time they were logged in. So let's say if we're like 2 days ago, the existing password would be a password hash, something like ejy blah 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 dot blah dot blah. Yeah. And the other details like the primary key and the email will definitely remain constant. So, but here's the catch, right? This state will change no matter what once a password reset is successful. Therefore, how Django does it is the token that gets sent to the user in their emails is just an encoded, either encoded or encrypted. I'll have to double down and check on that. It sends them an encoded version of this data. Now, let's say we would have something like, let's say django.com/reset/token/ let's say the user token is 1.ejy blah blah dot login timestamp 220088 whatever. That's not an accurate timestamp, but it's just for reference purposes. Dot email. Now when a user clicks this link, it would break down this into something that Django could work with on hitting the right routes. Now it could check for a user with that primary key with the existing hashed password as this, with the timestamp as whatever was passed in there, and with the email. Now here's the catch. Django does something called salt rounds. So salt rounds are a way of making sure that even if you hash the same password again, you would get a different hashed value because like the salt round changes. So picture this, you have a string. If you want to salt it, you put something maybe before, maybe after, it's completely up to the implementation of the algorithm, and then that thing it adds is random, then the string itself gets hashed. Now, for that same string to be hashed again later on, another random value would be added, changing the hash altogether. So like salt rounds, you could hash the same thing multiple times and get different values. So that's why that happens here. So let's say once this is met, a simple database query checks if all of these are valid, meaning this user passkey has this current password hash, and it might be like, oh yes, it's your password hash. It's not right to get into the wrong hands, but yeah, at the same time, it's important to realize that your password hash is practically useless because when you put it in a column, let's say like a password field, and you send a form, that password hash gets hashed into something else. So your password hash is practically useless for the most part. So if all these criteria are met, it allows the user to reset their password. Now, this is where it gets even more fascinating. Now, when a user resets their password successfully, the next state would be a logging state, meaning this could just as easily go from this to, let's say, since it's a new hash, we could have something like blah blah egyj dot blah. So now we have a new hash here, and the timestamp for the login would change to the currently last logged in time, which should be after the password reset. So let's say instead of 8811, let's say 8833, and the email would remain constant. Now, bear in mind that this token here is not going to appear as is, it will be digitally signed. So digitally signed strings, or rather digital signatures, are a way of ensuring that certain tokens or strings have not been tampered with from the original sender. So even if you were to get all of this information and you try to encode it, the digital signature would be the point of failure because the server would practically throw it away because that would be a request or a token that had been tampered with. Now, to ensure usability, one-time usability, let's say you have this string and you want to try it again. Now, when you hit this endpoint, Django would look at it and it would not be a match because, well, your password hash would no longer correspond and your timestamp would no longer correspond. So essentially, a way of handling password resets without the extra DB calls, without storing any new data or any new table in your database, would just be to take advantage of states that will change every time a password has been reset, and then cryptographically generate a token based off of that, have it digitally signed, right, and send it to the user via an email. And on clicking the email, let that link take them to an endpoint that processes this string, like the cryptographically generated token, and extracts the necessary data and checks back to make sure that it is a match. So this way you have a string that is usable exactly only once, cannot be tampered with, and gives you no room for security concerns. So it's very efficient and it works just like magic. So that brings me to the end of this video. To learn more stuff like this, feel free to like, subscribe, and engage with my video. Thank you so much for watching. Cheers.